So number 62 tells us that this is a graph of a negative fourth degree. Notice that the end behavior is what we're talking about in this one too. The negative makes it down, makes it flipped upside down, and because it's an even, the largest degree is even, it makes the ends together. So it's down and even. Down and the ends are together. So notice the end behavior looks like this. All right, so that rules out graph or choice D because D has a positive factor on the front of it, and we're looking for something that has a negative leading coefficient since it's flipped upside down. So it's either A, B, or C. The way we decide between those is the x-intercepts. This thing cuts through at -3, which means it must have been an x plus 3 when it was in factored form. Then it turns around and goes through 0. So that would be x minus or plus 0, which is just the x. And then it goes back up and bounces. Notice it bounces off 2. That would be x minus 2, and because it bounces, it's squared. It has an even multiplicity. Okay, and then this x minus 0, we just call that x and put it in the front. And because it is upside down, it has a negative in front of that. Okay, so you see that? The x-intercepts tell us how to factor it, and because it is upside down, it has a negative in front of that. Okay, then 63, we go the opposite direction. We have the polynomial in factored form, and then we use that to graph it. The even multiplicities, remember that makes it bounce off the graph. So just like that 2 bounced, had a square on it. It bounced off the graph. Same thing's going to happen to us on this next problem. So the x-intercepts at 2, positive 2, and it's bouncing there. -1, bouncing again. And then this would be x to the first, or like having an x minus 0, if it's just a plain old x, it means it goes through the origin. And that may be enough to look through the choices and tell, but I want to tell you about the end behavior, how you could figure out the degree of this. If this were all multiplied out together, this would be x squared with some other stuff, but x would be squared. This would have an x squared, and then times another x to the first. So adding those exponents together, it's x to the 5th. It's 5th degree, so the end should split apart, and the negative makes it go downhill. Negative flips it upside down or makes it a decreasing function. So it's negative odd, has end behavior like this, from high to low. So the graph is coming downhill on this end. It's bouncing, going up, hitting the 0. 0 is just to the first, so it cuts through, and then it bounces again on the 2 and goes downhill to infinity. So pick the graph that looks something like that. So is that A?
Yeah.
Okay, 64 is a shifting rule question. It just verbally says what would happen to this graph. And it has a shifting of +3 on the x. We do the opposite of what's in the parentheses grouped onto the x, so it's a +3 right shift, and then moved up 2. Is that C? Yeah, it should be C. Okay, number 65, and just so you know what section we're in, this would be section 3.5 in your book. This is the rational functions. We had a list of rules how to find the asymptotes of your function or the breaks in the graph. The vertical asymptotes, which that's not what they're asking here, but probably will in a minute. The vertical asymptote always has to do with the denominator. You set the denominator equal to 0 to find the vertical breaks in the graph. The horizontal breaks are more complicated. We have 3 situations, an A, B, C situation to figure out the horizontal breaks. They all have to do with the degree of the top and the bottom. The numerator's degree is 2. That just means the biggest exponent. The denominator's degree is also 2. The rule said if the degrees are the same, the horizontal break will be at y equals the leading coefficients divided. So y equals 9/8 should be the horizontal asymptote. Okay, number 66, also asking about that break in the graph. This time the degree is more on the top. So if the degree is 1 more than the denominator, denominator's to the first, if the degree is 1 more in the numerator than the denominator, you'll get a slanted break in the graph, or an oblique asymptote. You find that by long division, doing long division of this problem, or synthetic usually works since it's x to the first. We can say -9 divided into this polynomial, 1, -9, 3. Multiply and add your way across. And you throw away the remainder anyway, so it really didn't matter what that was, we're going to throw it out. But the equation that you have from your synthetic division is the equation of your slanted graph. Remember, synthetic division takes our polynomial 1 degree down, so it was x squared, so this is 1x minus 18. Y equals 1x minus 18 is the equation of that slanted or oblique asymptote.
Can you speak over a little bit? I'm sorry.
Yes, ma'am. Okay, number 67 is just graph this rational function, so you need to know where the asymptotes are though, so you can figure out which graph would work with it. So you need to know the vertical break is found with what makes the denominator equal 0. So the vertical asymptote is found by setting the denominator equal to 0, so that's at -5. And that's a guideline that my graph will have to deal with. And then the horizontal break is found by that ABC rule. It has to do with the degree. Right now the degree, if you look at this, the x is to the first on the top and the bottom. So that means, like one we just did earlier, if you have the same degree, you divide the numbers in front of that, which are 1s. 1 over 1, which is still 1. So y equals 1 for the horizontal, because it has the same degree. It's 1 divided by 1, which is 1. So I have a horizontal break in the graph at y is +1. So if you look at your choices, looks like there's 2 that meets that criteria, graph B and just graph B. If there were 2, though, that meets that criteria, I was looking at C, though, and it's down here below, so it's not. Graph B is the only one that has those exact guidelines. But if there were 2 solutions that both follow this grid, then you'd need to make a t-table to narrow down the choice. Figure out at least one other point on the graph so you can choose between those 2.
So how did you know they had the same degree because of the x?
Because the x, you go by the biggest exponent in your polynomial.
So it was 1 to 1, that's how you got 1.
And it was not these ones. It was the ones in front of it, the coefficients. The 1 and the 1 there is what made that. Okay, 68. So 68, we have the graph, and then we're going to go backwards. We've got the graph, and we need to figure out its equation. Notice it has a vertical break at -7, so it must have an x plus 7 in the denominator. And it also has a break at 0. We couldn't show the dotted line because it was right over top of the y-axis, but there is a break there, and you can tell on the graph it's not crossing that. There's something stopping it there. So there is a break at 0. So that would be you know, like this is x plus 7 because we changed the sign when we set it equal to 0. So this would be x plus 0 or x minus 0, which is just x. So in the denominator, we should have an x and an x plus 7, the two vertical breaks in your graph that you see visually. And right there, then you know it's graph D or choice D. But to figure out the numerator, there is a horizontal asymptote as well. You can tell this graph is hovering over that in those two places. It can cut through a horizontal asymptote one time, so it does do that. We talked about if you cross a horizontal asymptote, you can do it one time, but it doesn't cross back over. So that is acceptable, but it's definitely right above it and below it in the other two areas. Anyway, definitely a break at y equals 0, which is the horizontal asymptote. So for that to be true, for it to be 0, that means the numerator has to have a lower degree. That was that third situation where I said there's an ABC scenario that has to do with the degree. If the degree is the same, like on the one above, you divide the numbers in the lead. This would be y equals 1, a horizontal asymptote. If the top has a higher degree, you have a slanted oblique asymptote. But if the graph has an asymptote at 0 or the x-axis, it's because the numerator had a lower degree. So the degree right here is x squared. You've got x and an x. So the top can only have one x in it. So that rules out A and B, have too many x's, so it's either C or D. And then you could point plot to figure it out if you couldn't have enough clues at that point. But D is the only one that has the right vertical asymptotes, so it is x plus 4. And that concludes chapter 3 material. So any questions on that?
How'd you come up with the x plus 4 for the numerator?
Well,